Seated on my laptop screen, ready for the Python scene. All those lines of text so clean, let's code and chase that dream. Python world, here we go. Write the script, let it flow.
In this video, we're going to continue working with lists in Python. Specifically, we're going to take a look at how you can iterate or loop over the elements of a list, as well as how you can nest lists in other lists. We're going to get started by how we can iterate over a list's elements, that is, to loop through each one individually. The easiest way to iterate over each element of a list in Python is to simply use a for loop. We've seen previously how the for loop can loop over elements of a sequence, such as a string. In previous examples, we saw how we could loop through each character of a string by using a for loop, and that syntax is very similar for lists. Let's take a look at an example. In this example, we have a list of fruit. In this list called fruits, each element is a string that contains the name of a fruit: apple, banana, and cherry. Below that, we can see our for loop. In this case, the syntax is the same as we saw when we were looping over characters in a string. Fruit would be the element of the list, and fruits is the name of the list. So this loop will run once for each element in the list, and each time this loop runs, fruit will be equal to that element. This loop simply has a print statement that prints out the value of fruit. So this loop would run 3 times, and our output would be apple, banana, and cherry, which are the elements of the list. Now that's pretty straightforward so far, but there are some very important things we need to keep in mind while we're iterating over lists. And one of those is that that loop variable, in that last example was fruit, is just a copy of the value in the list. Editing that variable won't edit the list. Let's take a look at an example. And this is a bad example. Don't try this at home. So here we have a list called numbers, and it has the values 1, 2, 3, 4. But the problem with our loop is that we are trying to edit the loop variable. So in this case, num would be equal to each value in the list for each iteration of the loop. So it'd be equal to 1, then 2, then 3, then 4. But the problem here is we're trying to modify that value. We're trying to add 10 to it. Now that does modify the value of the loop variable. It assigns it a new value, but it doesn't affect the list. So if we were to actually run this code, the result would be the exact same list. This has no effect on the list. If we want to edit the values in the list, we have to use that index method that we saw in the last video and give the index for the value that we're updating. So please keep in mind that it's generally poor programming practice to edit the value of a loop variable. This usually isn't what you want to do, and it could be the sign that this is a bug in your code. It also makes it hard to understand and read your code, so try to avoid this if you can. So this raises the question, how can we loop over the indexes of a list rather than the values, so we can actually edit them or manipulate them in some way? Well, there's a few different ways we could do this in Python, but to stick with what we know, we can use the range function to do this when we combine it with the length function. Let's take a look at how. So here we have that same list that we saw before of fruits, but our for loop is set up a bit differently. In this case, we're not going to be looping over the values of the list. Instead, we're going to be looping over the indexes, the numbers 0, 1, and 2. The way this works is first we have a call to the length function. This is going to return the length of the list. In this case, we have 3 elements in our list, so the result is going to be the number 3. This is passed as an argument to the range function, which is going to create the sequence 0, 1, and 2. These are the index values for the fruits list. So this means I is going to start as being equal to 0, then 1, then 2. So we're not getting the values this time. Instead, we're getting the index values. Inside this loop, we have a fairly straightforward print statement that simply contains an f string. This f string is going to output the value I, which is the index of the loop, as well as the value that's in the fruits list at this index. So if it was index 0, we'd put 0, colon, and then apple, because apple is at index 0. If we run this, we would get the following output. The first value are the values of I. Each time the loop runs, I is incremented by 1 until we get to the end of the list. The second value we're outputting is going to be the values in the list at those indices. So the first time it's going to be equal to 0, and we get apple. Then it's going to be equal to 1, and we get banana. And then it's going to be equal to 2, and we get cherry. This can be quite useful to have access to both, as it will also allow us to manipulate the list, as we'll see shortly. So one advantage, as I mentioned, of looping over the values using range is that we can easily modify the values inside of the loop. So let's take a look at an example where we correctly add 10 to each one of these numbers. Previously, we didn't use range and it didn't work because we were only updating the loop variable. Now we can actually update the list. So just like in that previous example, we have a numbers list with the numbers 1, 2, 3, and 4. But now we are using that range method that we just saw to loop over the index values rather than the list values. So this means we're going to have a loop that runs from 0, 1, 2, and 3 for each index in the numbers list. And inside this loop, we are adding 10. But in this case, we're going to correctly modify the list because we're referring to the actual list using the index of each value, rather than trying to modify the loop variable. So when we run this, we can see that this list is correctly updated, and we get 11, 12, 13, and 14, which are the values 1, 2, 3, and 4, all with 10 added to them. So to give you a quick summary of these two different methods that we covered, direct access and indirect access in a loop, direct access accesses each element's value directly. The syntax is for element in list, and this works best when you only need the element values and you don't need to update the list at all. The advantage is more concise and easier to read code, but we lose access to that index value. Using the range method, or index access, allows us to access the elements by their index as well as have a copy of the index value. The syntax for that is for I in range length of the list, and this is great when you need both the index and the value. It can also be used to modify list elements by using their index. It's more complex to code, it doesn't look as nice, but it gives us more flexibility in what we can do in that loop. Let's now take a look at a more complex example. So in this case, we want to write a program that, given the following list of names, Alice, Bob, Eve, Charlie, Oscar, Diana, and Uma, we want to write a Python program that creates two new lists, a vowel names list and a consonant names list. The vowel names should only contain names that start with a vowel, and consonant names should only contain names that start with a consonant. The original list should not be modified, so we want to create two new lists with these values. We don't want to modify the old list. So what I'd like you to try is open up Python or PyCharm or whatever editor you'd like, and try to write a solution to this problem, using what we've covered so far about for loops and lists. If you get stuck, unpause the video and we'll take up the solution. Or if you just want to see the solution, you can keep playing and we'll go over it. I'll give you a chance to pause now. Okay, let's take up the solution. So I have the solution in the slide here, and we'll switch over to PyCharm now and take a closer look. Okay, we're in PyCharm now, and we have the solution loaded up. You can find this on the Learning Management System as EX 6.7. Now, remember, if you tried this yourself, that there are many different ways to do the same thing in programming and Python, so your solution might look a little bit different, but could still be correct. The best way to check is to actually test it out and make sure it's working. So at the beginning here, we have our list of names. This is just defining a list of strings that has each one of these names. We then define two new lists, one for the vowel names and one for the consonant names. In this case, both of these are being created as empty lists that have no elements. We then have a loop here, which is going to iterate over each name in our names list, and then going to add it to either vowel names or consonant names, depending on if it starts with a vowel or not. At the end, we will print out our results. So to give this a try, we're going to add a breakpoint and run it in debug mode. Okay, so we've run and we have paused right at this for loop. So we can see what's set up so far. We have a names list with our names. We have a vowels and consonants list, but they have nothing in them yet. So let's step into this for loop and see how this works. So we've entered the for loop, and remember this is looping through all of the different values in the names list. So we can see down here that name is currently equal to Alice because that's the first name in the list. Down here, we're saying name 0. So in this case, this is referring to the string name. So it's going to be the text Alice. So 0 here isn't referring to a list. It's not the first element of the list. It's the first character in name. Remember, name is not the same as names. Name is the current value in the list, which is equal to Alice. So name 0 would be a capital A, the first letter in Alice. We then use .lower to make that lowercase. So this is case-insensitive comparison. So we're going to have a result of a lowercase a. We're then using the in keyword to check if that lowercase a is in this string. And the string just has our vowels, A, E, I, O, N, U. In this case, it's going to be true. So we enter into the true part of the if statement. What this says is vowel names dot append the current name. So if it was a vowel that the word starts with, we are going to add the name to our vowel names list. Let's see that run. Okay, so we can see now vowel names has an element been added, which is the name Alice. We'll keep running the loop. And now we've entered the loop and the name is Bob. So we've moved to the next element in the names list, and that value is Bob. We're going to check, is B a vowel? It's not. So instead, we're going to run the else part of the loop, and we're going to add Bob to our consonant names list. So when we run that, we can see that this list gets Bob added as an element. We could keep doing this. It's going to go for each name, and it's going to add it to one of the lists. Because this is an if-else, every one has to be added to either one list or the other. And you can see now that we're done this loop, the vowel names have all the names that start with a vowel, Alice, Eve, Oscar, and Uma, and the consonant names have Bob, Charlie, and Diana. Now we are going to simply print out our results. So in this case, we're printing names, which is the full list of names, because we want to see that it wasn't modified. Remember, that was one of the rules of the problem. So if we take a look at the console, we can see it printed out the full list of names, and it hasn't been modified because these appends are only affecting the vowel names in the consonant names list. We'll go to the next line, and we ran names starting with vowels, and we outputted that list. And we got what we expect, Alice, Eve, Oscar, Uma. And we get the last line here, which is the list of consonant names. So hopefully this was fairly straightforward. If it wasn't, I do recommend trying it out yourself in PyCharm, tracing through it with debug mode, just to make sure you understand how everything's happening, how the lists are changing. You can even try changing around some of the code to see how it works. The best way to learn programming is by actually trying it out and making your own programs, rather than trying to memorize. So let's switch back to the slides and continue on. And we're back to the slides. In the slides, I also have the example output. Now, there is something I should warn you about, and that is trying to modify the values of a list by adding or removing an element while you're currently looping through that list. This can cause what we call unexpected or undefined behavior, which means Python could act in weird ways. So it's important to not use append, remove, or pop, or other operations or methods that could actually add or remove an element from a list while we're currently iterating over that list. So here's a bad example, something you shouldn't do. So here we have our fruit list again, except we've added a few new fruits. We have apples, bananas, berries, cherries, and dates. And what we have code here that seems like it should remove any fruit that starts with the letter B. But the issue is that we're removing an element from a list while we're currently iterating over it. And that's going to cause some undefined behavior, because we don't really know what's going to happen. If we remove banana in the list, are we going to go to berries, or are we going to jump to cherries? Is it going to cause an error? We don't really know. So it's best to avoid this. In this case, if we run it with my current version of Python, we get apples, berries, cherries, and date, which is not quite correct, at least probably not what we intended, because it didn't remove berries. Again, this can cause unexpected results. So please try to avoid modifying a list by adding or removing elements while you're currently looping through that list. There is a way to fix this, or at least solve it, and that is to make a copy of the list before you iterate over it. So the only change here is that we are calling the list function before we're looping through the list. So what this does is it creates a copy of our list. So this is a different list than the one we are modifying or removing fruits from. When we try this out, it will give us the correct result. So if you want to add or remove elements from a list that you're currently looping over, it's best to make a copy of that list first. Remember, the list function, if given a list, makes a copy of it with a new copy of the values. Now we're going to move on to using lists with functions. If you recall from our video on functions, Python uses a system called pass by assignment for passing arguments to functions. In simple terms, this means if that argument is mutable, we can edit it in the function and that result will be seen outside of the function. However, if that argument is immutable, then any changes inside the function won't be reflected outside the function. This is an important distinction for lists because lists are mutable. That means modifications made to a list inside of a function will affect the list outside of the function, because they are just references to the same object in memory, which we saw in our lists video. So once again, since lists are mutable, that means changes to them in a function will be reflected outside of that function. Let's take a look at an example. And here we have an add fruit function that's going to add a string, presumably the name of a fruit, to a list of fruits. Let's take a closer look and see how this works. So the first line here is simply defining our function. This sets it up, but Python doesn't run the function yet. The first actual line that's run is going to be creating our list. So this creates a list with two strings. One is apple and the other is banana. This might look something like this in memory. Remember that the variable fruits is a reference to this list. Next, we call the addFruit function. And this is going to pass not the list, but a reference to the list in the computer's memory. And we're also going to pass as an argument the string cherry to be added to the list. So what this effectively does is going to be creating a new reference to our list called fruit list, as well as a parameter fruit that has a reference to the string cherry. It's important that this is a reference because when we try to modify this list and add fruit by adding cherry to the list, it means that it is going to affect both the list outside and inside of the function because fruits and fruit lists point to the same list in the computer's memory. So cherry is added for both of them. So once the function is done, the program resumes after the call to the function. If we were to have a print line here so we could evaluate what the values of fruits is, we would see that cherry was added correctly. So keep this in mind, lists are passed by reference to functions in Python, and this means that modifying the list inside that function will affect the list outside of that function as well. Now, in addition to passing lists to functions, functions can also return a list. So it's common to see functions that create a list internally and then return a reference to that list. Returned lists can then be assigned to a new variable, enabling us to further manipulate or access that list outside of the function. Let's take a look at an example. And here we have a function called generateSquares that's going to create a list. This creates a list of the squares from 0 up to and not including the value of n that was passed to it. So in this case, the function first creates an empty list, then it has a loop that runs from 0 all the way up to 2, but not including n, and then it appends the value of I to the power of 2 for each one. So it would be 0 to the power of 2, then 1 to the power of 2, then 2 to the power of 2, all the way up to, but not including n. It then simply returns that list. Our program outside of the function assigns the value of that list to square list and then prints it out. And the result would be something like this: 0, 1, 4, 9, and 16, which are the squares from 0 up to and not including 5. Let's now look at a more complex example. And this uses both iterating over lists as well as sending and receiving lists from functions. And what it does is it allows us to curve student grades by a certain percentage, as well as separate the passing and failing grades into two different lists. So the first part of this problem up here is a function called curveGrades, which is going to take a list of grades and apply to a curve, a certain percentage bonus, to each grade in that list. The second function down here, called separate passing failing, is going to separate our list of grades into a list of failing grades, that would be those below 50 by default, and a list of passing grades, so those greater than or equal to the passing threshold, which is 50 by default. The rest of our code simply sets up our list and then calls these functions and prints out the results. Let's take a quick look in PyCharm. Here we are in PyCharm and we have example 6.9 loaded up. So we're going to go through this and take a look at how it works. First, we have the curve grades function. This takes our list of grades and the percentage to curve the grades by. We're going to add that much in terms of percentage to each grade. Inside this loop, we have a for loop. And this for loop is using that range method we saw before, where it takes the length of our list, grades, and then it's going to run from 0 all the way to 1 less than the length of the list, which should be the indices for every single element in the list, starting with I equals 0. Inside the for loop, we are updating the value of grades at I. So this would be the first element, then the second element, then the third element, and so on. And the way we're updating it is we are multiplying it by the percentage divided by 100 to get it to a decimal percentage, and we're adding 1 to it. So we'll increase that grade by the percentage given. And then we're storing that result back into grades at the same index. Now, since we don't want any students to have a grade over 100, we do have a check here to ensure none of the grades go above 100, and if they do, we just put that back to 100. So at the end of this list, it should have modified grades so that every single grade in the list is increased by that percentage. You'll notice there's no return here because it's not needed. Remember, lists are mutable, so that means that modifying the list in the function changes that list outside of the function as well. The other function we have here is separate passing failing. And what this does is it takes in our list of grades as well as a passing threshold, and it separates them into two different lists. The passing threshold has a default value of 50. So by default, if we don't give a passing threshold, they have to be greater than or equal to 50 to pass. The way this works is the function creates two new lists, a passing list, and it starts it off as an empty list, a failing list, and it starts that off as an empty list, and it then uses a for loop to loop through every value in grades. So in this case, we're using the method where we just loop through the values because we don't need the indexes in this case because we're not modifying grades at all. In this for loop, we are checking if their current grade is over the passing threshold. If it is, we add it to the passing list. Otherwise, we add it to the failing list. Then we return two lists, the passing list and the failing list. So this doesn't modify grades at all. Then down here, we have the code that drives this program. We're creating a list of grades to test this with. We're curving the grades by 5%. Then we print out the curved grades. Then we get the passing list and the failing list by calling separate passing failing. And then we print out those results. One interesting thing here is we're using that same tuple unpacking that we saw before to return more than one list at the same time from this function. And that's completely okay. Any kind of value can be used in this sort of tuple unpacking. So let's run this and see how it works. We'll add a breakpoint right here. And we'll run it in debug mode. Okay, so we're at this point here. We've seen that our student list, or student grades rather, has been set up and it's in the memory. And now we are going to step into the curve grades function. Okay, so we've started the curve grades function, and we can see that the parameter curve percent is set to 5, and the parameter grades is a reference to that same list that we have here. As we enter in this loop, we can see that we get an index I starting at 0, and that's going to run all the way up to 7. Now we're modifying the first grade because I is equal to 0. We're going to be modifying the grade at index 0, which would be 55. And you can see 55 was updated to 57.75. We're going to check if that's over 100. It's not. So we're going to restart the loop. And this is going to keep going, and it's going to be adding that 5% to each grade until we eventually get to index 7, which is the last one. We do the check. If it's over 100, it's not. And we exit that function up here. Okay, and we have returned from the function, and we can see student grades from outside the function has been modified. Because we passed a reference to this list to the function, it means the modifications from inside the function are also present in the list outside of the function. And now the next line is going to print out that list to the console, and we can see that the modifications are still intact, even though we're outside. Next, we're going to call separate passing failing, and we're actually going to be giving it the modified list, Because remember, this list was modified, so it's no longer the values 55, 68, and so on, it's 57.75. So that modified list is going to be sent to the separate passing failing function, and let's see what that does. So now we're inside that function. We'll take a look at the variables, and it's going to set up passing and failing. And both of these are going to be initialized to an empty list. And we're going to add to these lists as we go through this loop here. This loop here is going to go through all of the values in the grades list. Because we're not using range here, we're going to go through each value. That means we can't update the value of the list, but we don't need to because we're just creating two new lists. So when we enter this loop, the first value of grades is going to be 57.75 because that's the first value in the list. So every time the loop restarts, we go to the next value. And we're going to check, is that above the passing threshold, which was defaulted to 50. So the current value of the passing threshold parameter is 50. In this case, 57.75 is a pass. So we add that to the passing list using the append method. And we can see passing was updated to have a new element called, or with the value of 57.75. The loop continues, and it now goes to the next value, which is 71.4. And we do the same thing, adding it to the passing list. And we keep doing this until we eventually find a grade that doesn't meet this threshold, in which case the else case is triggered, and we add that grade to the failing list. And you can see failing was updated with 47.25. It keeps doing this for every value in the list, adding it to one of the lists, until eventually we finish and get to the return statement. So it's important to note here that this doesn't in any way modify the grades list, it's just creating two new lists by copying those values into them. Now for the return, we're going to be returning two references to lists. We're going to be returning a reference to the passing list and a reference to the failing list. Remember, this is part of tuple unpacking, so this will create a new tuple and return that with both lists. Now you can see we're back outside of the function and we resumed on the next line after calling it. And you can see we now have a reference to passing grades and a reference to failing grades, which are those lists that were created by the function. So we returned two lists at once from this function. So functions can create lists and we can use them outside of the function, so long as we get a reference to them. Now we're finally just going to output the passing list and the failing list. So we'll run that line and we can see the passing grades in the console. And now we can see the failing grades, and that's the last line, so we're done the function. So I do recommend trying this out yourself in PyCharm, as well as playing around with different breakpoints and tracing through how it works. Let's switch back now to our slides. And we're back to the slides, and if you're following along with the slides, I also have a copy of the output in our slides. Let's move on now to nested lists. So a nested list is simply a list that contains other lists as its elements. Remember, lists and tuples can have any sort of data object inside of them, and this includes other containers like lists or tuples. And by nesting lists, this allows us to represent more complex data structures and multi-dimensional data like tables, matrices, or groups of related items. Let's take a look at an example. So here we have a fairly simple nested list. This nested list is called medal count, and it contains the counts of medals from the last Olympics for each one of these countries. So the order is the country name, then the number of gold medals, the number of silver medals, and then the number of bronze medals. We can take a closer look at how this works in terms of the computer's memory. So the data we're trying to represent is the data in this table. Like we said, nested lists are good at representing tables of data. And you can see that we have both outer square brackets and inner square brackets. And the way this is working is we're making a reference to a list, which is a list of lists. So see, each element in this list called medal count is actually a reference to another list. So we could represent that like this. So the element at index 0 would be a list for Canada and has the name Canada in it, as well as all of Canada's medals. The list at index 1 would be the list for USA, and it would contain the text USA followed by all of USA's medals for the last Olympics. So how can we reference these specific data elements? Well, like I said, we can reference these different lists by using the standard indices. And in this case, metal count 0 would give us the first list, metal count 1, the second list, 2, third list, and so on until the end of the list. But what if we want to reference a very specific data element? Like maybe we just want the name Canada or how many gold medals Canada got. Well, we can do that too, and the answer is to add a second subscript in square brackets. So medal count 00 would mean the first list, the first element. So that would be the text Canada. Medal count 03 would mean the first list, and then the very last element, or in this case, it would be the fourth element, which would be the number of bronze medals Canada got, which in this case would be 11. We can also access different lists. So in this case, 32 would be accessed by the third list, which would be at index 2, and it would be the third value in that list, which again would be index 2, and that would result in 32. So what I'd like you to try to do is come up with the statement you need to use to access the number of gold medals for Great Britain and the number of bronze medals for Australia here. And remember, you need to do this by saying medal count and then giving it two indices, the list indice and then the actual value indice. I'll put a timer up, but feel free to pause it if you need more time. After the timer's done, we'll take it up.
Lines of code on screen again. Python's flowing through my pen. Hourglass is running out. Gotta solve this right, no doubt. Deadline's looming, it's so tight. Tick-tock goes the clock at night. Functions, loops, and ifs and else's. Each line fixes all my messes. Coding fast, time is slipping. Got no pause, pressure's gripping. Python rhythm, keep on beating. Countdown timers, never cheating. In the zone, my mind's a maze. Debugging errors that we face. Syntax highlight, guiding way. Hope to reach the break of day. In the zone, my mind's amazed. Debugging errors that we face. Syntax highlight, guiding way. Hope to reach the break of day. Seconds to spare, hearts are racing. Pulling through each iteration. A variable dreams never ending.
And we're back. Let's take a look at the solutions. So to access the gold medals for Great Britain, we would say medal count 4, which gives us the fifth list. And then we would say 1 to get the second value, which is the number of gold medals. For Australia, it would be medal count 5, which would be the very last list in our list of lists. And we would say 3 to get the last value, which is the bronze medals in that list. So using these two indices, we can access any value in this table. Specifically, they are shown here. So 00 would be the very first value in the first list, and 53 would be the very last value in the last list, with each one having a unique combination of indices. It's important to note that this is just for two-dimensional lists. If we started adding more dimensions, more data into this, maybe make it a 3D table, we would have to start adding more and more indices. For 3 dimensions, you need 3 indices, 4 dimensions, 4 indices, and so on. So let's take a look now at an example that's actually in Python. So here we have that nested medal count list, and we're going to be trying to print out a few different values. The first value here is going to print out the whole list. And you can see it's a bit cut off here in this output, but Python is trying to format this all on one line for us, so we can see this nested list. Note the double square brackets means that this second list is inside of this first list here. So this is basically just printing out the whole list. Now the next line is a bit more interesting. It's printing out the list at index 0. So in this case, we get the list for Canada, which has the text Canada, as well as the gold, silver, and bronze medal counts for Canada. The next line is accessing a specific value. So we're saying the first list at index 0, and we want third index in that list, which will be the last value, which is the count of bronze medals. So by not providing an indice, like in that second print line, we can access the list as a whole, or we can put no indices at all to access the outer nested list. So one very important thing that we should mention is the length function might work differently than what you expect when your list has nested data. And that's because length returns the number of elements in the outer list. It's going to tell you how many lists there are in your list of lists. It's not going to tell you how many elements there are in total. So this might be a little bit different than what you expect. So if we call the length function on a two-dimensional list on the outer list, just like its variable name, it's going to return the number of rows in that list rather than the total number of elements. If we want to get the number of columns, we could do the length of the first element, or any element really, in that list, as long as we only give one indice, because that's going to refer to the list at index 0. So that would be the length of the list at index 0, which should be equal to the number of columns. If we do want the number of elements in total, we have to do a little bit of math, and that would be multiplying the number of rows by the number of columns. But it is important to note that this is only true for two-dimensional nested lists that all have the same number of columns. Python does allow us to have each list being of a different size in a nested list, in which case it would be a little bit more complicated to figure out the total number of elements. So that's a bit complicated, so let's take a look at a practical example. Here we have the metal counts list, and we have 3 different print lines. One's printing out the length of metal counts, one's printing out the length of metal counts at index 0, and one is printing out the total number of elements. So the first one finds the number of rows, the second the number of columns, and the last is going to find the total number of elements in metal counts. If we run this, we would get the following output. But just saying length metal counts is going to tell us the number of rows, which is equal to the number of countries in this case. So in this case, we have 6 rows or 6 countries. The next is going to give us the number of columns, and we can find this by taking the length of the value, or the list rather, at index 0. So this would be that list for Canada, and we can see Canada has 4 elements. Canada, the number of gold medals, number of silver medals, and then the number of bronze medals. So this gives us the number of columns if we're assuming that each list inside this list has the same number of elements. Then last, to find the total number of elements in this list, we can multiply the rows by the columns. So 6 times 4 in this case is equal to 24. Just keep in mind, this only works if each one of these lists has the same number of elements. If we had something weird, like some countries didn't have any bronze medals, then we'd have to do a little bit more work to find the total number of elements. So let's take a look at a more practical example. And here we have an example problem using that medal list again. Now we want to print out this medal list, but we don't want to just print it out. We also want to calculate the total number of medals and produce something that looks like this. So we print out each list in our list of lists, and then we should have the number of gold medals, number of silver medals, number of bronze medals, and a total. And the solution is going to look something like this. Let's explore it in PyCharm. Okay, here we are, and we have example 610 open. The first thing we do in this program is we set up our medal counts. Again, this is a nested list, so it's a list of lists, and each list contains the text for the country name, followed by their medal counts, gold, silver, and bronze. Now, the next part of this program is just outputting the headers for that table that we saw. So it's just going to put out the text country, a bunch of spaces, the text gold, some spaces silver, some spaces bronze, some spaces and a pipe character, and then total, and the next line is going to be a bunch of dashes. This is just to make it pretty, and so we know what the different columns are in our table. The real meat of the program is going to be this for loop here, and there is something new in this that we haven't seen before. So first, we're going to loop through all of the indices in the list. Again, this is using that range method, which takes account for the number of rows in the list. Since this is a two-dimensional list, that means the length is going to be the number of rows. So this isn't going to return 24, the number of elements. It's going to return the number of rows, which is 6. 1, 2, 3, 4, 5, and 6. That means this for loop is going to run through the number 0 all the way up to, but not including 6, which would be 5. So this is going to give us a loop variable I that represents the current row we're in. Inside of this loop, we are setting total equal to 0. This is where we're going to keep track of the total for this country. It's important that this is in the for loop and not outside of it, because it needs to be reset for each country. Otherwise, the total would include the total for the last country. And now we have a second for loop. So we have a nested loop structure here. So in this case, this loop is going to run from 1 instead of 0, because we're giving a starting value of 1, all the way up to, but not including, the number of columns. So k here is going to be the loop variable that's responsible for keeping track of what column we're currently on. The reason why we're starting at 1 rather than 0 is we want to skip the country name. We just want to add the total number of metals. So this inner loop is responsible for adding up all the metal totals. Inside here, we have metal counts, and we are accessing a specific value. So I would be the row number. The first time it would be 0, so it would be for Canada, and k would be the column number. So in this case, we would start with column 1 because we're starting at 1. So it would be the gold metals. Then we go to the bronze metals, go to the silver metals, and then the bronze metals. And each time it's adding them to the total. This loop would end after we access the bronze metals for Canada. Then we are going to print out the values. And this is where that new thing I mentioned comes in. So we're using an F string here, and we're using a new feature of the F string. You may recall us doing a colon and then an F, or a colon and then like .2f to output a floating point value with a specific number of decimal places. Well, another notation that F string supports is this sort of less than symbol and then a number. This means we want to print out this text, and we want it to take up exactly 15 characters. So if the text is less than 15 characters, it's going to add spaces at the end to space it out. This is great because we want our list formatted in a specific way. If we didn't have this, then everything would be pushed in and nothing would be nice and lined up. So this just means print out metal counts, index I, so for the first time we're running, that'd be for the Canada list, at element 0 or column 0. So that'd be the name Canada. We're going to print that out, and we're going to add spaces after it until it adds up to 15 characters. Next, we're going to print out metal counts I, so the current row we are on in the metal counts in the loop, and then the element at column 1. So that would be the number of gold metals. Then we do the same thing for silver and bronze, and that's a bit off the screen here. But we print the pipe character and then our total that we just calculated. So let's run this program and see how it works. We'll add a little debug symbol here so we can run it in debug mode. Okay, so we've paused right at the for loop, and we can see that we have our two-dimensional list set up, and it's printing it all in one line here. If we wanted, we could expand this and we could see at different indices. So at indices 0, we have this list for Canada, 1, we have US, and so on. And we could even expand that to see the indices of each value. So 0 would be the actual text Canada, 1 would be 7, and so on. Now we're going to enter the loop. So this loop is starting at 0, which is going to represent row 0. We then set up total, and we're going to have total equal to 0. That's our total count of the number of metals. And we're going to enter this second for loop. This for loop is going to start with k equal to 1, and that's going to represent our column numbers. Then we are going to access the value at the given row and column for I and k, and we're going to add that to our total. So that's going to be a 7 the first time, then a 6, then 11. Let's see that happen. Okay, we've added the 7 to our total, and it runs again, and then we're going to add the next value to our total for the silver metals, and then we're going to add the next value, which is the bronze metals. After we've run that for each column in the current row, we then exit this for loop and continue on with the line after it, which is going to print our output, which is going to be the country name for the current row, which is row 0. It's going to be the gold metal count, the silver metal count, the bronze metal count, and then the total number of metals. And let's take a look at that in the console. So you see, we got Canada, 7, 6, 11, and 24 for the values. After we run this line, the loop is going to restart, and I is going to be updated to the next value, which is going to be 1. So we're moving from the first list for Canada to the second row at index I equals 1, and that's going to be for USA. We're going to do the same thing again. Total is reset back to 0, and we're going to run through this inner loop and count up all of the metals for USA. Let's do that now. Okay, we've added up all the metals for USA, and it was 113. And now this line is going to output all the data to the console for us. And you can see we got USA with 39, 41, 33, and a total of 113. It's going to do the exact same thing for each country. We're restarting the loop now, and we are now going to index 2, which is going to be for China. So it's going to go through all the Chinese values, and it's going to add them up to get a total metal count. We'll just go through that quickly, and we'll go through until we eventually get to the end. Take a look at the console so we can see them being output as we go. And this is going to keep going until we reach the end. And that was Australia. And since Australia was the last list in our list of lists, we then exit the program, because after the for loop, there's no other lines. And you can see we got this nicely formatted list of countries. Again, what this is doing, the less than 15, is making sure there's at least 15 spaces. So however many letters are in Canada, subtracted by 15 would be how many spaces are here. Make sure that these always take up at least 15 spaces. Same thing with the 8 here, is making sure that this number here takes up at least 8 spaces. If there's only one character, it's going to add 7 spaces after it. Same thing with this for silver, and for bronze, and for total. And this is great because it makes a nice consistent list here. If we were trying to use spaces or tabs manually, we would probably get all of mixed up data. It wouldn't be all in nice columns like this. Okay, let's switch back to the slides and keep going. That's all I have for you in this lecture. If any of these concepts are a bit unclear to you, I highly recommend trying some of those examples that we reviewed. They'll be really helpful in understanding lists, how you loop through lists, and how you nest lists together. Nesting lists and multi-dimensional lists can be a difficult topic, and the best way to learn that is through practice. So try coding up some of those examples yourself, as well as try chasing through some of the examples that we've provided. Again, you can find those attached to underneath the video in the resources box on our learning management system. Thank you for watching, and have a great day.